Before the dawn of steam, man harnessed power from his own labours, livestock and from the elements, but the energy output would always be limited and restrictive. This was the age of reason, of enlightenment, a time when Britain began its unfettered journey towards leading the world in science, technology, trade, commerce and even empire building. Thomas Newcomen was an English inventor. Born in Dartmouth, Devon in 1664, he became an ironmonger by trade. And in 1712, Newcomen built his first atmospheric steam engine, which was used to pump water from the bottom of mines. The machine was a beam engine that condensed steam to create a vacuum. That in turn allowed the atmospheric air pressure to push down on a piston which was contained within the condensing cylinder, which is about as clear as mud for most people. So let's take a look at this machine in cross section. Here we have the furnace, using coal as fuel to heat up the water inside the boiler. This generates steam, which then enters the condensing cylinder when a valve is opened. The inlet valve is then closed and a jet of cold water is sprayed into the condensing cylinder. This causes the steam to rapidly cool and creates a vacuum. As the external pressure is now greater than that within the cylinder, it pushes the piston down and the cycle is then repeated. In Newcomen's design, it isn't the steam which forces the piston back up to the top of the condensing cylinder. The beam is actually weighted more on the side of the pump connecting rod, and it's this weighting which pulls the piston back up as the cylinder's pressure is gradually equalised with the external atmospheric pressure. In earlier designs, the valves, or plugs as they were then called, were manually operated by a plugman, but this cyclical action had to be accurate, and it was therefore more preferable to have this operation automated. Now it may look a little Heath Robinson, but with the introduction of a plug tree connected to the beam action, Newcomen was able to accomplish this task. James Watt was a Scottish inventor born in Greenock in 1736. It was whilst Watt was working as a mechanical engineer and instrument maker at the University of Glasgow that he was asked to repair a working model of Newcomen's steam engine. He came to realise that Newcomen's engine design was less than efficient. With every stroke, energy was being wasted as the condensing cylinder was being repeatedly heated and then cooled. Watt's solution to this problem was to build a steam engine that incorporated a separate condenser. Watt sporadically developed his engine between 1763 and 1775, and as we can already see, there's a little bit more to this than that of Newcomen's engine. So let's take a moment to examine its main features. It's the combined furnace and boiler that produces the steam, which is then transferred through the steam pipe to a series of inlet and exhaust valves, which in turn are connected to the piston cylinder. The piston is connected to the beam, which operates the rotary arm, one end of which is a static cog known as the planet, and that appears to rotate about another cog known as the sun, and it's this sun and planet gears which operate the flywheel. We also have a cold water tank and a hot water tank. In this cross section, we can see that Watt's engine is double acting. That's to say that steam enters the cylinder at each end alternately, forcing the piston up or down. This process is controlled by the engine's valve gear, shown here in this cutaway. Active steam alternately enters the valve systems at these points here, whilst the exhaust steam exits the system through these pipes, all of which is controlled by a plug tray or rod, which is again linked to the beam. Here we can see the exhaust steam pipe leading into the cold water tank, in which are housed two cylinders. This is a separate condenser, and the other is a pump which extracts the condensate into the separate hot water tank, which then recirculates back to the boiler. There's still a number of innovative features about these steam engines which I've still not mentioned, and I may come back to those at a later date. Well, I hope you've enjoyed. I'll catch you later.